Right, question 14. Right, first of all we have to write down the points. What's the point A? Tell me. Jausa? What's the point A?
1 and 1.
1, 1. What's the point B? 11, 1. Alright, 1, 1 and 11, 1. Mark the point 6, 8. And so you have to go 6 and keep on going up until you get to 8. Right, that's 6, 8. And right. Find the coordinates of right, so that's D, alright? A, B, D. Find the coordinates of C, the midpoint of A, B. So you can just do that simply by going in 1. So starting at 11 and 1. In. There it is. We're going to call that C. So what's the coordinates? 6, 1, isn't it? C is 6, 1. Everybody got that far? Join A to D. Join A to D. And then it says join C to D. Join A, D, B, D, and C, D. Use the distance formula to find AD and BD. AD and BD. Right, are you watching? Are you looking up? We'll write down what A is first. So A is 1, 1, and then D was 6, 8. B was 11, 1, and D 6, 8. Now use the distance formula. Right, so if you watch, we'll do the left hand side first. So first of all you mark it x1, y1, x2, y2. Write down your formula, x2 minus x1 squared plus y2 minus y1 squared. And you fill in all the values as you go along. Alright, so x2, first of all, from above is 6. Follow the formula, minus x1 is 1, plus y2 from above is 8, minus y1 above is 1 squared. Now you do the addition or subtraction. Inside 6 minus 1 is 5, 8 minus 1 is 7 squared. So that's 35 plus 5 squared is 5 times 5 is 35, sorry 25. And 7 times 7 is 49, and add the two of them together. 25 plus 49 is 74. Right, then we find the distance between B and D. Same idea, same formula. x2 minus x1 squared plus right, so we have to mark it x1, y1, x2, y2. Are you watching? Yeah. So call it out there, Ethan. x2.
Minus x.
Alright, x2 is what, first of all?
6 minus 8.
6 minus x1?
11.
11. Plus y2
8.
minus
1.
right, 6 minus 11 is minus 5, isn't it? Squared plus 8 minus 1 is minus 7. Oh, it's 7 squared. Minus 5 times minus 5, that's is 25. And 7 times 7 is 49. And if you add the two, you get the same answer. BD is equal to square root of 74. Now the two distances are the same, aren't they? So AD, the line AD is the same as the line BD. So if you look at the diagram above, this is AD and BD. Two lines have the same distance. Next page. What type of triangle is ABD? ABD. This one here. What type of triangle? Is it equilateral?
Yeah.
Is it? Let's have a look. The length of that line is 10. This is, yeah, two sides are the same, two angles are the same, these two sides are the same. So it's an isosceles triangle. Type isosceles. Reason, two sides have the same length. Sorry, two sides have the same length. State whether the triangle ACD and BCD are congruent. So first of all, ACD, that triangle. And the second triangle is BCD, this one here. What does congruent mean? The same in every way. Are those two triangles the same? Have they got the same angles and the same lengths of sides? Do they?
Yeah.
Right. First of all, this side, is that the same length as this side?
Yeah.
Yeah. So the way we write it down is, are they congruent? Yes. First of all, the first reason, AC is equal to CB. So those two sides are equal. AC on the triangle on the left, and this triangle here, is equal to BC. Those two lines are equal. See this line here? Isn't that on both triangles as well? Isn't it?
Yes.
So DC is the same on both triangles. DC is the same on both triangles, isn't it? What other side is the same on length on both triangles? This side. So this one, AD is equal to BD. See that? All three sides are equal in length, aren't they?
Yes.
So, therefore, the triangle ACD, I'm just writing this stuff down again, is congruent. Three lines means congruent to triangle BCD. Alright, congruent means the same size, the same length, the same angles.